Hey guys, welcome to the first example video, with this one being on function notation. Okay, so if you remember from the lecture, function notation's base definition is simply f of x equals y, with f being our function name, x being our input, and y being our output. So what's great about this is in the past we've used equations like y equals 3x plus 1. The problem with this is if I have multiple equations, I don't know one from the other. They're all just y equals y equals y equals. But with this, we can rename them f, g, and h are our typical three. We can rename them different things, so that way we get a better kind of ability to manipulate multiple things going on at one time. What's also nice about this is equals, right? If two things are equal, I can replace one for the other. So if f of x equals y, I can just replace this y with f of x, giving us our symbolic form of this function using function notation. F of x equals 3x plus 1. Easy enough, right? So that's our basic idea of how to kind of write a function in function notation. Now, how do we work with that? What do we do with it? Some simple things we can do are evaluate this function. And what the question would say would be like, evaluate the following. And I may give you a list of things like, say, f of 2, f of negative 3. I can even do some crazy stuff like f of x plus 4. So I'm going to go through and we're going to evaluate all three of these. And the way we do that is really simple. Okay? When we look here at this function notation name, okay, this x is a placeholder, right? We can almost think of this as f of blank. Okay, and whatever is in here, right, whatever is in place in this parenthesis replaces this x over here. So this is just our placeholder, it's our variable, right? So in this first one, it's asking f of 2. So that means I replace this x with a 2. So I get 3 times 2 plus 1. Now I'm running out of room here, so we're going to kind of do some stuff mentally. 3 times 2 is... I'm waiting for you. What is it? That's right, 6. Plus 1 gives us 7. Sorry, I'm a dad and do dumb things. So, next one, f of negative 3. We do the exact same thing, right? I'm just going to take whatever is inside these parentheses, and I'm going to use that to replace this x here. So we get 3 times negative 3 plus 1. Again, run out of room, so 3 times negative 3. Well, 3 times 3 is 9. Since one of them is negative, not the other, so we have a negative 9. Negative 9 plus 1, negative 8. Okay? So when we have a single value inside the parentheses of function notation, it's really fairly simple. We take that value, replace any of the variables in the function expression, and evaluate. Now, what about when we get something like this? Right? We have an x here. Well, we already had an x here, right? Remember, this is just the general placeholder for whatever is inside the parentheses. So here, all we're going to do, let me kind of jump down a little bit, give myself some room, is I'm still just going to exactly like what I did here. I'm going to replace this x with whatever is inside these parentheses. So I'm going to get 3 times whatever is inside the parentheses. So in this case, it's x plus 4. And then plus 1. Now we can just simplify this, right? Use some distribution. Right? We get 3 times x gives me 3x. 3 times positive 4 gives me positive 12. Plus 1. In our final line, we get 3x plus 13. Okay? That's it. That is how we can use function notation to evaluate a function. Now, that's not all we can do. Okay, so we'll stick with our function f of x, 3x equals 3x plus 1. With this, we can ask to evaluate things like we just did, but we can also say for what x is f of x equal to negative 20. Okay? So here, again, kind of going back to the beginning of this video where I said we talked about that equals thing, right? If two things are equal, I can replace one for the other. So here, we know that f of x equals negative 20, which means I can replace this f of x with negative 20. And so all this is really doing is just creating an equation. Negative 20 equals 3x plus 1. That's easy, right? Subtract 1 from both sides. Those cancel each other out. Negative 21 equals 3x. Divide by 3. Those cancel. And we get x equals negative 7. There we have it. So when x equals negative 7, f of x will equal negative 20. So we can answer questions like this, right? These are the types of questions we can be asked as well with function notation, just like any other problem. Okay? All right. Now, this was all using that symbolic form of a function, right? So if you watch the rest of that video, if you didn't pause and jump over to this video, right, this is that symbolic form. Okay, we can also answer these same questions using graphs and tables, right? Those are numerical forms and graphical forms. You can do it still with verbal forms, we just don't. So here's a random function, right? This is the function g of x, okay? Now, we don't know anything about g of x. We don't know that it is a line or quadratic or anything like that. The only thing we know is that when x is negative 1, g of x is 5. When x is 0, g of x is 23. And when x is 1, g of x is 17. That's it. So, I mean, easy things with this, right? G of 0 equals, well, 23, right? Because if x, the thing that goes inside here, is 0, g of x is 23, okay? I could also, do similar things. G of x equals 17, so x equals 1. Because if g of x is 17, then x must be 1. Easy, right? Now, let's give myself some more room. Pause if you need to write this down. All right. What if we have a graph? All right. Standard xy axis, except it said now we're calling it an x h of x, right? Because h of x equals y, so we can just replace them. So let's think what kind of function I want to do. Let's just kind of make one up. Let's go like that. And similar off here. You may recognize what the type of function this is, and that's great. Okay, but we don't need to, right? So cool, easy questions we can ask. Right? What's h of 0? Well, this is telling me that the x value, or the value on our horizontal axis, needs to be 0. So we go to where it's 0. We go find where the function is, and it's 2. So this equals 2. Easy enough, right? We can also do similar things like if h of x equals 2, x equals. So this time we're given an h of x value, not an x value. So if we're given an h of x value, that's on our vertical axis. We want it to be 2. And hey, look, that means x is 0. Really easy, right? So we just need to read these things and understand them, right? We just need to remember that when we're dealing with function notation, the x is our input. And the y is the output. If we know that, we can figure any of these things out, okay? And just keep it simple. Don't overcomplicate these issues. Whatever is in here goes in place of the x in the equation, okay? Hope you guys like that video. If not, oh well. But if you have any questions, please leave a comment in the forums, okay? I will have a forum up for the Foundations video set. Okay, that's already in the folder with Foundations video, the Foundation video questions, Foundation video quiz, Foundation assignment. Okay, so there's a little form in there so you can ask questions specifically to these videos and get any help. All right, guys. See you later.